So in class yesterday, we were able to complete our unit circle based upon what we know about our two special right triangles, the 30-60-90 triangle and the 45-45-90 triangle. And in this particular example that I'd like to do with you that refers back to that unit circle, we ask you what the largest possible value of cosine of theta is, and then the largest possible value of sine of theta. Now, for reasons that we discussed in class yesterday, we learned that the x-coordinate of any point on that unit circle is equal to the cosine of theta, and the y-coordinate of any point on that unit circle is equal to the sine of theta. So you can see that if we're talking about the cosine of theta and its largest possible value, well, we've got cosines that are 1, 0, and lots of values in between, -1, 0, and lots of values in between as well. So when we ask about the largest possible value of the cosine, you see that the largest x-coordinate of any point on this circle is equal to 1. So cosine can never exceed 1. Also, you see that cosine can never be less than -1. Now, as it concerns sine of theta, we need to look at the y-coordinates of the points on this unit circle. Well, we've got y-coordinates of 0 and 1 and everything in between, and 0 and -1 and everything in between. So the sine of theta, you see, has the largest possible value up here at +1. So each of them has the largest possible value equal to 1, and you'll notice that each of them has the smallest possible value equal to -1. Now in my next example, I ask you to use the unit circle and to the nearest thousandth determine the coordinates of the image of the point 1, 0 under a rotation of 25 degrees. So again, let's picture our unit circle. And the location of 1, 0 is right here. And we remember from geometry, when we rotate a positive magnitude, that means we're moving in a counterclockwise direction. So from this point, 1, 0, if we rotate around the origin in a counterclockwise direction, and we go a total of 25 degrees, we'd land probably somewhere right around there. Well, again, we know that every x-coordinate on the unit circle has it can be found by taking the cosine of the angle of rotation, and every y-coordinate can be found by taking the sine of that angle of rotation. So our x-coordinate of this rotation will be whatever we get when we take the cosine of 25 degrees, and our y-coordinate of this point on the unit circle will be whatever we get when we take the sine of 25 degrees. Well, if you find those values on your unit circle, you find that to the nearest thousandth, the cosine would be at 0.906, and the sine at 0.423. That's where the image would lie if we rotate the point 1, 0 counterclockwise 25 degrees. In this example, we ask you to explain how to use the unit circle to find each value. And in the first example, find the sine of 270 degrees. Well, again, our starting point is always this point here at 1, 0. If our magnitude, in other words, angle of rotation, is positive, we know that that means we need to go 270 degrees in a counterclockwise direction. Well, starting at 1, 0, if I rotate here, that's 90 degrees. If I keep going, that's another 90 degrees, so that's 180. If I keep going, that's another 90 degrees, so that's a total of 270 degrees of rotation. Sine, we know, is the y-coordinate. So our y-coordinate here, where we land, is at -1. So the sine of 270 degrees is equal to -1. On the other hand, notice in my other example, cosine of negative 270 degrees, we're giving you a negative magnitude. So that means from the point 1, 0, we don't want you to rotate counterclockwise, but rather in a clockwise direction. So if I rotate from 1, 0 to here, that's negative 90 degrees. If I keep going, that's negative 180 degrees. If I continue on, that's negative 270 degrees. Well, cosine is the x-coordinate of that point, and that in this case would be 0. So the cosine of negative 270 degrees is 0. Here we want you to determine the exact value for each of these trig ratios. So the sine of 450 degrees. Again, we always want to begin at our starting point, which is at 1, 0. Notice this angle that we're finding the sine of is positive, so that's a counterclockwise direction. So from 1, 0, we're going to go counterclockwise. Here's 90, 180, 270, plus 90 is 360. If I go 90 more, I'll land right here on my unit circle. And the y-coordinate there, we know, is 1. So the sine of 450 degrees is 1. In the second example, I ask for the cosine of 720 degrees. So and again, the magnitude is positive, so continue moving in a counterclockwise direction. We're at 450 degrees here. Another 90 would be 540. Another 90 would be 630. Another 90 would be 720. We'd land right here on the unit circle. But this time cosine is the x-coordinate, so the cosine of 720 would be 1. Now in our final example here, we ask you to evaluate, without using a calculator, the sum of cosine 270 plus sine 270. Well, here's our 270 degree angle, again, if we were to start our rotation from this point at 1, 0. The coordinates of that point we know are at 0, negative 1. The cosine is the x-coordinate, so the cosine of 270 would be 0, and the sine is the y-coordinate, so the sine of 270 would be negative 1. So when we evaluate the sum of those, well, 0 plus negative 1 is negative 1. So guys, we're just going to do lots and lots and lots of this rotating around the unit circle here in these lessons, always starting at the point 1, 0, and remembering that the x-coordinate is the cosine, coordinate is the sine. So the question is, have we hit our targets? Well, yesterday we talked about finding the exact values of those trig functions that are multiples of 30, so 30, 60, 90, 120, and so on, or multiples of 45, so 45, 90, 135, 180, and so on. We filled in our unit circle yesterday with all of those cosines and sines. We of course know that their tangents can be found by taking sine divided by cosine. We're also using the properties of the unit circle to find lots of different trigonometric values by just rotating around the unit circle, starting always at the point 1, 0.